So cosmic forces turned Venus into a planetary barbecue. But on this violent, stormy world, time and the elements have produced some of the strongest thunderstorms ever measured. Welcome to Saturn. Lightning cuts the sky. This violent weather system grows bigger than the entire United States as it pummels the atmosphere with the most powerful lightning ever seen. Except this lightning can't be seen, because these bolts are electrifying the skies over Saturn. Despite the raw power of Saturn's lightning, scientists have been unable to see it, partly because Saturn's rings are too bright.
The rings are so bright, if you were on the night side of Saturn, it would be considerably brighter than the Earth under a full moon.
But Saturn also hides its lightning within thick, choking clouds of ammonia.
It's probably 100 kilometers down that the lightning is happening, and that complicates seeing the lightning flashes.
But the lightning is there, and scientists know it because they've heard it. Radio wave detectors on the Cassini orbiter have recorded the sound of Saturn's lightning.
We can hear the static of lightning just as you could with an AM radio going down the highway on Earth.
And this static reveals the power of the lightning that we can't see.
You can measure the energy in those radio waves and compare it with the energy that your radio picks up when there's a thunderstorm around on Earth. And the Saturn ones are big. They're more powerful, maybe 100 times.
And Earth's lightning can help scientists understand how storms work on Saturn. Within Earth's storm clouds, just like in Saturn's, updrafts drive moisture higher, causing ice to form. These ice crystals rub against each other, take on a positive charge, and become attracted to negatively charged water droplets lower in the cloud. This sets the stage for a potentially powerful discharge of energy.
Once you get that charge separation that builds up so intensely that some theorize that it can be as strong as 100 million volts, that the cloud then must release that energy.
On Saturn, the same thing happens on a much larger scale. In fact, the lightning is 100 times stronger than Earth's. That's a staggering 10 billion volts of electricity. Thunderstorms in Saturn's southern hemisphere span thousands of miles and can last as long as a month. But scientists aren't sure what makes Saturn's storms bigger and longer lasting. It could be Saturn's supersaturated atmosphere.
Probably the fact that there's more water in the atmosphere, pound for pound, on Saturn makes the storms bigger.
More water droplets means more friction, which means bigger lightning bolts. But energy emerging from the planet may also contribute to the power in Saturn's thunderstorms.
It turns out that where Lightning Alley is on Saturn is a place where the winds are flowing the slowest. If you go deep down in the atmosphere, you'll see the same winds as you do up high. It's a place where the energy being released deep down below can make it on up to the upper atmosphere without being sheared apart, and allows storm systems to be organized.
Earth's atmosphere isn't built that way. So, as violent as our storms get, they're nothing compared to the systems on Saturn. Even a run-of-the-mill mega thunderstorm on Saturn would devastate us here.
The Saturn medium-sized thunderstorm on the Earth would mean a thunderstorm that grows to cover all of North America and presumably has very strong winds and rain. This is something that's unprecedented on the Earth.
Saturn's hyperviolent thunderstorms are proof that our planetary neighbors have weather far more ferocious than ours. But the laws of physics that create Saturn's storms are the same laws that create our own weather. Massive dust storms, unrelenting winds, killer lightning, powerful hurricanes, and searing heat.
Mars, the red planet, fourth rock from the sun. For centuries, we humans have gazed at our neighbor and imagined an alien world. And as human technology advanced and telescopes brought it closer, we began to see signs of life.
As the 20th century began, mainstream credentialed astronomers were looking at Mars, thinking that they saw evidence for a society, a civilization on the red planet.
We Earthlings braced for contact. If there was life on Mars, what form would it take? We set off into space to find out. But as we approached the red planet, we discovered a new mystery.
All the elements needed for life were there, so what happened? Where did everybody go?
Mars is almost Shakespearean, a beguiling world. It's tricking us every way.
So Mars, dead or alive? Some think Mars was home to an ancient civilization.
There was at one time intelligent life on Mars, and they built something.
But the evidence continues to elude us.
If there's life there, we'll find it.
Across the globe, the race is on for the greatest discovery of all. Join skeptics and believers alike as we try to answer the age-old question, is there life on Mars? If you're planning a trip to the planet Mars, here are a few travel tips to help make your journey as comfortable and rewarding as possible. All in all, the expedition will take about 2.5 years, including approximately 12 months aboard your interplanetary spaceship. So make yourself comfortable. Plan your provisions carefully. You'll need to bring plenty of water. At this time, there's no liquid H2O anywhere on the planet's surface. You'll also need an effective spacesuit and a sufficient supply of breathable air. Finally, remember, Mars is about 1.5 times further from the sun than Earth, which makes this a cold world. The temperature can drop to a chilly minus 130 degrees Fahrenheit. So dress warmly. These technical issues aside, Mars has a lot to offer. It is home to the largest known volcano in our solar system, a magnificent Grand Canyon, and breathtaking deserts. For those of you interested in culture, a visit to the notorious Face is a must. We know you have a choice, so thank you for choosing the planet Mars. All in all, without ever setting foot on Mars, we know a lot about this distant world. But what we don't know is, what about life? When the first astronauts arrive on Mars, who or what will they find? Will aliens be there to greet us? Or is no one there at all? Inquiring minds want to know, is there life on Mars? It's a big question, and a fundamental one, because really, it's synonymous with the question of, are we alone in the universe?
If we go to Mars and find evidence that there was life on Mars or is life on Mars, then we'd be able to say that in our own solar system, life appeared twice. I think that would be convincing evidence that the universe is full of life.
Discovering life on Mars could also reveal a lot about our own existence.
We have one kind of life adapted to one planet, even with all of its diversity. So looking at the way other planets may have given rise to a phenomenon that we would recognize as life can enable us to understand our own kind of life in a deep and fundamental way.
The stakes are high in the game of life, and Mars may hold the key.
If we're going to find proof of life on Mars, we're going to have to go to Mars to get it.
But getting to Mars isn't exactly easy. The Apollo astronauts took about 2 days to get to the moon. A journey to Mars one way is roughly 7 months. Mars takes about twice as long to orbit the sun as Earth. So a space mission has to plan departure when the two planets are close. The challenge of bringing a mission back is incalculable in complexity. Just one of the reasons no manned mission has ever been attempted. But that's exactly what Dr. Robert Zubrin of the Mars Society wants to do. Bob Zubrin, an astronautical engineer with 15 years of experience in the space industry, has been planning a trip to Mars for the last 2 decades, and he's come up with a novel way to do it.
If we want to go to Mars, we need to travel light, live off the land.
What makes a Mars mission so prohibitively expensive is the amount of mass, mostly rocket propellant, you have to send there and back. Instead, Dr. Zubrin came up with the following plan. Take supplies enough to get there, then make what you need on the planet.
There's 3 things we want to make on Mars. First, most importantly, propellant. After that, water. And third, oxygen. We can make all 3 with this machine.
Here's how the machine works.
The Martian atmosphere is 95% carbon dioxide gas. We pump that into the reactor. We mix that with a little bit of hydrogen. You can make that reaction produce either methane or carbon monoxide or any mixture of the two. And water.
The methane and carbon monoxide mixtures can be used as rocket propellants for the return trip to Earth.
The water, we could keep the water and drink it, or we could electrolyze it into hydrogen and oxygen. The oxygen that comes off, we could use as breathing oxygen, we could use as rocket propelled oxygen. That's how the machine works. It makes your fuel, it makes your oxygen, it makes your water.
And leaves enough room on your spaceship for food. All in all, it looks simple enough, and it's not just theory. Working with simulated Martian air, Zubrin has spent years testing and refining the technology.
This is a subscale methane, carbon monoxide, oxygen rocket engine. It all works. It works great. These are great propellants. We start them right up with a spark plug time after time.
In a way, Zubrin has done all this to make a point. Current thinking is that it is too expensive and dangerous to send a manned mission to Mars. Instead, the international space community has deployed a range of unmanned robotic explorers on and around the planet. But Zubrin points out using robots to do field research leaves a lot to be desired.
Okay, we can send robots to Mars, and I support sending robots to Mars. I think we want to send a lot more robots to Mars. Okay, robots can make all kinds of discoveries. They can give us all kinds of data. They can image the surface of the planet and possibly identify interesting targets for exploration, but they won't tell us the answers that we need to know. They won't tell us if there's life on Mars.
So does Zubrin expect to find life on the Red Planet?
I think that a naturalistic view of the universe would suggest that the Earth is not special, and that if life can evolve here, it could evolve elsewhere where environmental conditions are similar. And if there's life there, we'll find it.
But perhaps there's an easier way to find out. The answer could already be here on Earth. Every year, hundreds, maybe thousands of aliens come to our planet. Most arrive quietly and go unnoticed. Others enter the atmosphere in a blaze of glory. These aliens are meteorites. For centuries, these rocks from the sky were treated as curiosities, often ending up in local museums or private collections. But the information meteorites contain is so valuable that today, the scientific community sends out search parties to gather them. Although meteorites fall randomly all over the Earth, one of the most popular hunting grounds is Antarctica. Every year, scores of scientists take their lives in their hands and head to the frozen continent. The teams conduct a systematic grid search of the icy landscape, looking for telltale dark shapes against the blue-white of the ice. It was on an expedition such as this that a meteorite was found that would shake the scientific community to the core. The team sent it to a special facility, at the Johnson Space Center in Houston. Because this is where NASA keeps the aliens. 84001, or the Allen Hills meteorite. The strange green rock was kept under strict quarantine. It was processed, examined, and rigorously interrogated for information about its home world. It took 10 years, but investigators finally got the truth. This rock was from Mars, and it had a secret to tell.
Today, Rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life.
So what was it the rock told us? We'll come back to that a little later. But perhaps the best evidence of life on Mars is not hidden deep in an alien rock. There are some who believe a vital clue is staring us right in the face. Richard Hoagland has dedicated his life to examining imagery transmitted to Earth from various Mars orbiters. Surveillance systems that have circled the red planet for over 30 years now. In the first pictures that the 1976 Viking orbiters sent back from the planet's surface, Hoagland saw something that blew his mind.
I looked at this and it was like, oh my God. This thing had symmetry, it had proportion, it looked like a statue.
Hoagland is referring to this remarkable image, a face-like structure the size of multiple city blocks. And Hoagland thought he saw more. Other structures surrounding the icon, eroded by time. To him, it looked like the ruins of a monumental city.
It looked eerily like an aerial photograph taken flying over Giza, looking down at the pyramids on the Giza Plateau. It looked like a ceremonial complex built by somebody with a huge sphinx-like creature staring up into space from the sands of Mars at the telescope orbiting 1,000 miles overhead. Somebody was down there, and they cared enough to leave the very best.
Needless to say, Hoagland's theory raises more than a few eyebrows. But did life on Mars ever exist? Was there once an ancient civilization of alien life forms? And if so, where did they go? Believe it or not, the idea that Mars was occupied by a race of intelligent extraterrestrials was not the creation of science fiction, but science fact. In the early days of humankind, Mars burned faintly red in the night sky, leading some to equate it with a mighty god, naturally, the god of war. But then astrologers, using a new contraption called the telescope, determined that those lights in the sky might be planets, much like ours. This meant there might be other civilizations, other life forms out there. And Mars was about to become the star attraction. Thanks to Italian astronomer Giovanni Schiaparelli. In 1877, Schiaparelli trained his telescope on the Martian surface and observed the existence of canali. By this, he meant natural channels. But due to an unfortunate translation, these channels became canals, which implied a man-made phenomenon. To fully understand the impact of this, consider that only a few years earlier, human engineers had completed the awe-inspiring Suez Canal. It defied nature and geography by linking the Mediterranean and Red Seas. It was considered the latest wonder of the modern world. Whether or not Schiaparelli believed the canals to be made or natural, the word itself sparked the public imagination. If there were canals on Mars big enough to see from Earth, really intelligent beings must have built them. The rumor was dramatically compounded by an American astronomer named Percival Lowell. Lowell was a highly respected man of good society who had a profound love of astronomy. He developed a fascination with the canals of Mars and sat up through the nights observing the red planet. And what Lowell thought he saw in the wee hours was a dying world crisscrossed by constructed waterways. Perhaps, he wrote, creatures short on water have built an irrigation system that circled the planet. By the turn of the 20th century, the idea that Mars was occupied had hit the mainstream media. New York Times headline, 1911. Martians build 2 immense canals in 2 years. Martian civilization was usually perceived as being ahead of us in evolution. And each earthbound nation projected onto Martian society the diverse vision and fears of its own future. In this 1924 movie from Russia, Mars is portrayed as going through a proletariat revolution and ending up successfully communist. But many thought that Mars was dying, and some said it was only a matter of time before Martians tried to contact us. And so, some thought, they did. Through another new technology.
This is Seth Shostak. Go ahead, caller.
Radio. Astronomer Seth Shostak takes up the story.
It goes right back to those early radio pioneers, and none so directly as to Nikola Tesla.
One of the most brilliant electrical engineers of all time, Nikola Tesla, was the first to claim someone from beyond this planet was trying to get our attention. In 1899, Tesla was experimenting with an electric invention that essentially acted as a large antenna when he noted something strange. Repetitive signals which were substantially different from the signals he had noted from storms and earth noise.
And it's only natural to imagine that he would ascribe this to some sort of intelligent beings, because as far as Tesla knew, only transmitters could make radio sounds. So he naturally assumed that if he heard something, somebody was broadcasting it.
In fact, Tesla was probably mistaken, as Shostak often gets to explain on his weekly SETI radio show.
Well, we don't know for sure what Tesla heard, but most likely it was something that we call whistlers. These are just distant thunderstorms, lightning discharges that produce natural radio waves that get distorted by the atmosphere as they propagate around the Earth and make a sound that kind of sounds like a whistle.
Modern science may have an explanation, but in a way, Tesla was ahead of his time. The idea that you could send signals from one planet to another made sense and inspired subsequent radio enthusiasts to listen for signals from outer space.
A guy by the name of David Todd realized that in 1924 there was a real opportunity to listen for the Martians. And the reason was that in 1924 you once again had one of those circumstances where Mars and the Earth got close to one another. So he organized an effort to get people to stop transmitting for 5 minutes every couple of hours so that people with the right equipment could actually listen, and this included the military, to listen for signals that might be coming from Mars or some other planet.
But whatever the message might have been, it seems we humans didn't get it. At which point, the Martians turned nasty.
Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News.
In 1938, Mars attacked. Turns out it was apocryphal, an imaginative radio play based on the H.G. Wells book, War of the Worlds. But many believed it and thought Earth was under imminent threat from aliens.
Now, mind you, it wasn't so unreasonable. I mean, there were places that really were being invaded at the end of the 1930s, after all. So the mindset of the public was kind of attuned to the idea of hostile forces coming in and taking over.
And sure enough, they came. Martians, great and small, came out of the skies and landed in our movie theaters. Sometimes they looked like giant insects. Mostly they seemed suspiciously human-like, and they came in a bewildering variety of shapes and sizes. They had laser guns, evaporators, death rays, and deadly kisses. They wanted gold, weapons, earth women, and human blood. One thing's for sure, they were very rarely friendly. Next thing you know, real flying saucers were being reported from San Fran to Timbuktu, and the phenomenon of alien abductions was born. The world, it seemed, had gone crazy for extraterrestrials. For all its downside, the popular imagination paved the way for mankind to make that giant leap. In 8 years, the U.S. built a transport system and became a spacefaring people. Perhaps we were determined to bring democracy to the communists on Mars. In fact, we only got as far as the moon. And while there were no aliens up there, you might argue that if we could make the trip, then extraterrestrial life, capable of interplanetary flight, was at least a possibility. So what about Mars? As our technology got better, we sent a robotic scout to the red planet. The landing was a success. The robot touched down, turned on the camera, and we finally got a good look at Mars. It wasn't what we expected.
How disappointing after centuries of assumption that Mars was inhabited, that it had cities, it had canals, and the reality was that it was just this terrible, awful, dead-looking place.
Ladies and gentlemen, we regret to inform you, Mars is dead. Or is it? Mars may be unoccupied now, but if we're to believe Richard Hoagland, the red planet once hosted a magnificent civilization. Hoagland is the principal investigator of the Enterprise mission, a loose collection of scientists, researchers, and Mars enthusiasts. They've spent years trying to prove this extraordinary theory. For Hoagland, it boils down to this.
If I had one catchphrase to describe the whole problem of convincing scientists that there is really an ancient civilization on Mars, it would be, it's the geometry.
Take the face-like structure from this 1976 Viking orbiter image. NASA claims it's a naturally occurring rock formation. Richard Hoagland thinks there's more to it.
If you actually look at proportions, where the mouth is, where the nose is, where the eyes are, they conform to commonly accepted statues and representations of human forms that go back literally thousands of years.
And Hoagland has found what he believes to be a highly complex geometric relationship between various structures centered around the face. Hoagland claims that the layout of this region, named Cydonia, is similar to what we see in ancient ceremonial complexes on Earth.
There are alignments, there's parallelisms, there's right-angle rectilinearity. They also appear to have a specific geometric relationship to the face, to another massive structure down here, to other structures.
To prove his theory, Hoagland and his colleagues have applied a series of computer image analysis programs, looking for, well, basically things that don't match the surrounding landscape. And the face and a couple of other structures register as anomalies, implying, he says, artificial constructions.
This is the real image, and this is the fractal representation. And again, it's the signal strength is basically...
Strictly speaking, a computer will find whatever you program it to look for. It doesn't actually determine whether or not the artifact is natural. But Hoagland claims there are some things you can see for yourself. Take this pyramid, an apparently perfect tetrahedral form with an accurate apex and sharp angles.
This unquestionably had to be made by someone because nature does not produce this kind of structure. If we were to land someday, find the entrances to this thing, walk inside, because if the exterior is preserved in this extraordinarily pristine form, imagine what waits us on the inside.
But if there was a civilization, what happened?
That's where things get interesting, but that's where we obviously cross the line from science to speculation. We have no ground truth, unfortunately.
So why isn't NASA all over this? Hoagland thinks the government is hiding something.
I believe there's a cover-up. Call it a conspiracy if you will, except they're not called conspiracies, they're called policies.
And why? Well, according to Hoagland, it goes back to an obscure Brookings Institution study commissioned by NASA and published in 1960.
There is a section devoted to the implications of NASA's discovery of extraterrestrial life. And the document recommended that if we were to discover, i.e. NASA were to discover evidence of extraterrestrials, that it should be basically kept secret because it had the potential at the limit to destroy civilization.
The argument seems to be that where a civilization comes into contact with one more technologically advanced, that civilization's in trouble. So does this mean the government is covering up aliens to prevent a societal meltdown? It's a bit of a stretch when you consider that all the Brookings report actually suggested was that we should do more studies. Hardly sinister stuff. Seth Shostak thinks there's a fundamental flaw in Hoagland's cover-up theory.
Well, doggone it, if the aliens are really here and they're really advanced and they're really malevolent, as they could conceivably be, then it really doesn't matter what the government does it? This is Bambi meets Godzilla, and Godzilla's gonna win.
This from someone who believes there's life beyond Earth. Shostak works for an organization that operates on the assumption that not only is there life out there, some of it has technology. This is the Allen Telescope Array, built and operated by the University of California at Berkeley and the SETI Institute. SETI stands for the Search for Extraterrestrial Intelligence. It may seem out there, but SETI is an entirely scientific operation, manned by astrophysicists, engineers, and planetary scientists. Their objective is simple.
It's really easy to send signals between the stars. That's the bottom line fact. There might be thousands, millions, or more societies that are sending information from one star system to the other. Why not look for it?
SETI is essentially eavesdropping on the universe in an attempt to pick up a signal from outer space. To do this, SETI uses highly sensitive radio receivers that scan systematically through the billions of star systems in our universe. It's like scanning through your car radio dial as you travel cross-country, but on a cosmic scale.
Now, what kind of signal are we looking for? We don't care. Looking for the message requires a different kind of technology that we haven't built and won't build until we find that they're on the air. We're just looking for a signal that tells us, hey, their transmitter switch is on.
It may seem like looking for a needle in a haystack, but astronomy has made enormous progress in identifying the stars and planets beyond our solar system, which, combined with ever-improving technology, allows SETI to search with more precision. The motive, however, is as old as mankind itself.
We're trying to look for something that would show that, we're part of a bigger picture. We're not just a little bit of chemistry run amok on this small little world tucked away in the corner of a nondescript galaxy in an enormous universe.
So the million-dollar question, of course, has SETI made contact?
In 1997, we picked up a signal using the telescope in West Virginia that looked like the real thing. And we got quite excited, to the point where everybody was glued around the computer monitors just looking at what was going on.
The signal had all the qualities SETI looks for in an alien contact. It occurred on a very narrow frequency. This is key because while nature produces radio waves aplenty, they are like broad static across the dial. This one was emanating from a specific location in the cosmos. Throughout the night, scientists were on the edge of their seats trying to pin down the source.
I realized that the world from that day forward will really not be the same. I was very nervous, actually, because I didn't know what the consequences were going to be.
It took 3 days, but the engineers and scientists finally identified the signal, and it wasn't alien.
As it turned out, the signal was due to a European research satellite, the SOHO satellite, the signal of which had just gotten into the structure of our antenna. And that was a bit disappointing.
In conclusion, then, the industry experts, SETI, have not yet found any evidence of extraterrestrial intelligence.
As of now, one thing you can say, and that is we have not conclusively proven the existence of any life, intelligent or not intelligent, beyond the bounds of Earth.
And what about Mars? Martian monuments aside, you'd be forgiven for thinking that 30 years of remote observation has done nothing but confirm our nearest neighbor is dead. But in fact, life on Mars has begun to make a comeback. It's all about water. When NASA scientist Chris McKay saw those 1976 Viking images of a dry, barren Mars, he was intrigued.
I remember the overwhelming impression I got was, the lights are on, but nobody's home.
What McKay is referring to is what he poetically calls the ghost of water past. He's offered to meet us in the Mojave Desert to explain.
There's no water in this lake bed now, but the geology, the surface of the ground, shows evidence that there was water here. And that's what we see on Mars. We see dry lake beds. We see river beds that have no water in them, but clearly did at one time. And this is the evidence that Mars had water. And it's that water that's of interest to us from a biological point of view.
Although, in fact, the Mojave gets a whopping 5 inches of rainfall every year, Dr. McKay uses this desert as a near waterless zone to conduct experiments relevant to his theory about Mars. And life, it seems, can thrive nicely in these conditions.
We find microscopic life, microscopic algae, that have learned to survive under dry conditions. This organism, this algae, is the dry version of pond scum. They wait out in the dry for months, maybe years, and then a rain comes and they very quickly set up shop and do their biological thing, and then it gets dry and they shut down and wait again.
Dr. McKay certainly isn't claiming that Mars is populated by desert algae, but he thinks the odds are in favor of past life.
If we were to imagine what would the last Martian have been like as Mars went from a fairly wet, Earth-like environment to the dry desert that it is today, it would have been probably an organism like this.
Microbes? So much for the Martian monsters of the silver screen. But microbes bring us full circle. The fact is, some scientists believe we've already found life on Mars. And it's all because of mysterious clues in a Martian meteorite. Turns out our favorite Martian may be more like our favorite microbe. The 1976 Viking mission to Mars was a triumph of modern space exploration. But one unexpected bonus was information that could be used to further study our alien visitors. The unidentified meteorites sitting in cold storage on Earth.
Well, we've had meteorites we've known were meteorites for 100 years, but we didn't know they came from Mars until Viking landed and measured the gases in the atmosphere, and scientists studied the gases in these meteorites and showed that they were the same.
But how does a Martian rock get to Earth? Scientists think that some explosion, probably caused by the impact of an asteroid hitting Mars, blasts a rock off the planet and into space. It then hurtles around our solar system until, if it's very lucky, it gets caught by the gravity of our blue-green planet and plunges to Earth. Imagine the odds. For NASA scientist Dr. Everett Gibson, this event began a remarkable voyage of discovery.
For one to have life, you have to have the presence of water, you have to have the presence of carbon, you have to have an energy source, and you have to have geological processes. All of these 4 fundamental things are seen within the Martian meteorites. So, the conditions could be right for life to exist on Mars, perhaps in the past.
And it seemed the NASA team was about to prove it. Thanks to that odd little meteorite, 84001, from Mars.
600 million years after this rock was formed in the crust of Mars, you get water percolating through the rocks, saturated in carbon dioxide from the Martian atmosphere. As the water basically evaporates away, it potentially leaves the carbonate behind.
So the meteorite confirmed that Mars had once been wet, but there's more.
The carbonates contain organic matter. The carbonates contain an iron oxide mineral, magnetite.
Here on Earth, magnetite, essentially magnetic crystals, are often produced by microscopic life forms. This was getting exciting. Using the most powerful microscope at their disposal, the investigators now looked even closer and got the surprise of their careers. They saw what looked like minute worm-shaped structures. Quietly elated, the scientists were cautious.
We said one explanation could have been biology operating. Could have been the signatures of something like a life process.
So was this finally confirmation of life on Mars? Well, from the moment they were announced, the microbes have been controversial. Critics say that the carbonates, organic matter, and magnetite crystals can be explained through other non-life processes, and many believe that the worm-like structures are actually clumps of a coating material used to examine the sample in the laboratory. Still, others point out that the rock could have been contaminated at any time, perhaps when it was lying around for thousands of years here on Earth. Nevertheless, the possibility of ancient Martian bacteria raised the ante on life on Mars. If once upon a time Mars was warmer and wetter, and had some early form of microbial life, did it survive, thrive, and grow up to build like an Egyptian? Well, it's a nice idea, but seems unlikely when you consider that conditions on Mars are dry, radioactive, and extremely cold. How could anything survive in this hostile environment? But we could be underestimating the nature of life itself. Microbial life, that is. Believe it or not, astrobiologist Penny Boston is searching for life on Mars by dropping deep into this heart of darkness. This is a lava tube, a subterranean cave formed by underground lava flows during volcanic eruptions that occurred thousands of years ago. And Boston has someone she wants us to meet.
Sometimes they're in crevices, sometimes they're kind of hard to see.
Is this when the scary monster reveals itself?
Ah, there's one.
Actually, no. This is an extremophile.
We're looking for what we astrobiologists call extremophiles in this environment, and that means that they're organisms that are living in very difficult conditions. In this particular case, these organisms are living in a very cold cave right around freezing. They are making their living without benefit of sunlight, and there's almost nothing to eat in this cave.
In recent years, scientists have discovered tenacious microorganisms living in all forms of extreme environments. So if on Earth, why not on Mars?
We think
Welcome to our neighborhood. The Milky Way is just one of over 100 billion galaxies in the universe. And our sun, it's just one of over 100 billion stars in the Milky Way. We used to think of each star like our sun, as a friendly beacon amid the long night of space. Now we know better. The universe wields violence beyond comprehension. Forces capable of tearing space and time to shreds. I'm Liam Neeson. We're going to take a trip to the dark side, straight inside a black hole. Cape Canaveral, Florida. Our quest to understand black holes is about to enter a whole new dimension. Tucked into the nose of a rocket is a telescope called SWIFT. Its mission? To hunt for perhaps the most elusive objects in the cosmos. Black holes are so dense, not even light can escape their gravity. They defy detection. But today, hopes are riding high. Scientists are counting on SWIFT to transport them to the frontiers of human knowledge. And beyond. How do you find something that hides in the dark? you have to look for its telltale signs. Swift's instruments are designed to record bursts of high-energy radiation. Gamma rays don't penetrate Earth's atmosphere, but out here in space, Swift's view of them is front row center. They erupt when a black hole is born. That happens when a large star dies in a blaze of glory called a supernova. It's an explosion so powerful, it's as bright as a billion suns. What triggers that chain of events is the force that rules the cosmos: gravity. Scientists used to think of gravity as some kind of mysterious power that objects like the sun project across space. But what if it's space itself that gives gravity its pull? That's the way one man saw it. To Albert Einstein, space is a bendable, four-dimensional fabric he called space-time. And gravity? That's the warping of the fabric by massive bodies. They literally put a dent in space-time. Objects get caught in their groove and simply drop into orbit. Einstein's theory was a radical notion, all the more when taken to its extreme. Just how warped could space get? Scientists found the answer in a singular class of star, more than 25 times the mass of our sun. It's earned its name, a red supergiant. This star will live only a few million years, a fraction of our own sun's lifetime. Deep inside, the crush of gravity sends temperatures soaring above 1 billion degrees. Lighter elements fuse into heavier ones. Hydrogen becomes helium, becomes carbon, on up to iron. The core grows so heavy, it buckles in on itself. Then, the collapse sends a shockwave roaring out. The star digs itself deeper into space-time as a black hole forms at its center, and the giant goes supernova. When the dust settles, what's left is a black hole, an object 1 million times the mass of Earth, but 1 million times smaller. A black hole is literally a puncture in the fabric of space-time. Venture closer, and gravity becomes a riptide. It's like riding a raging river that's pulling you faster and faster toward a waterfall. The closer you get, the stronger the current. You're headed for a point of no return. In cosmic terms, it's called the event horizon. Over this edge, there's no escape, not even for a beam of light. Black holes are gravity to the max, and yet they are altogether commonplace. Astronomers have actually detected dozens of black holes in our galaxy. They estimate there are tens of millions more. But then gravity doesn't stop there. It turns out there's a whole other breed of black hole out there. Peering into galaxies beyond our Milky Way, astronomers have found that nearly every one harbors an immense black hole at its center. One galaxy, steals the show. It's called M87, and it's got a black hole 4 billion times the mass of our Sun. It has left its signature, a powerful jet erupting out at nearly the speed of light. Where does a hole this ferocious come from? To find out, turn back the cosmic clock 14 billion years to the beginning of the universe. The Big Bang. Matter and energy rush outward as the universe expands. To learn where supermassive black holes came from, scientists have recreated these early times with supercomputer simulations. They can trace the long, steady process that formed galaxies. From the start, gravity reigns in the cosmos. It draws together the primordial gases. These aren't gentle clouds. As they grow more and more dense, they heat up. Over millions of years, they become hot enough to ignite. The first stars are born. They end their lives in powerful supernovae, while their cores collapse into black holes. Billions of years later, and across billions of light years, Swift is today scanning the heavens for these same early supernovae. It's helping us learn what became of those black holes that formed in their wake. Astronomers believe some grew huge by plowing their way to the centers of their host galaxies, where they gorged on a rich supply of gas and stars. Some black holes grew larger still when they crossed paths with others. This scientific simulation traces the collision of galaxies, a drama that plays out over 2 billion years' time. The two galaxies become one. The black holes in their centers merge into a single powerhouse of staggering size. The gas hurtling into it gets jammed, heats up, and erupts in ferocious waves. Blast waves from supermassive black holes can stretch for thousands of light years into space. They may lay the framework of the new galaxy, sculpting its size and shape, and stocking it with something unexpected. Black holes may be one of the chief ways galaxies get seeded with elements generated by stars, with carbon, oxygen, and iron, the stuff of solar systems, and us. So how did our galaxy make out in all this? Astronomer Andrea Ghez wants to know, have we got a supermassive black hole of our own? For more than a decade, she and her team have been coming to the heights of Hawaii's Mauna Kea volcano to find out. Working at the giant Keck telescope, Andrea is tracking a strange presence in the center of our galaxy. A group of stars is swirling around it, and she's clocking their speeds, projecting their orbits. Her telescope is so powerful, it can peer through the thick of the Milky Way, through 26,000 light years of cosmic dust, all the way to the stars at the galactic center. Whatever's got them in its grip, it's accelerating the ones closest to speeds of up to 3 million miles per hour. Given that, Andrea Andrea and her team calculate that the culprit weighs in at almost 4 million times the mass of our sun. Solid evidence that at the exact center of our galaxy lurks a supermassive black hole. Andrea has confirmed the black hole is there without actually seeing it. So we're left to wonder, what's it like up close and personal? We can stop wondering and pay the monster of the Milky Way a visit. There's no spacecraft heading there anytime soon, but that's not stopping us. We'll get there courtesy of the latest telescope observations and computer models. We're just leaving the suburb where we live, about halfway out from the center of the galaxy. The Milky Way stretches before us. It's so large that it takes a beam of light 100,000 years to cross from one end to the other. Next stop, our galaxy's central hub, brimming with stars, known simply as the bulge. The farther we travel from our quiet cul-de-sac, the more crowded it gets. Up ahead, it's one big traffic jam of dust, stars, and hot gas, and it's always rush hour. Approaching dead center. The way is already strewn with signs of havoc. Supernova remnants and swirling clouds. Our course so far has been charted by astronomers like Andrea. They've plotted the landmarks by how they register across the light spectrum, from radio waves to X-rays. But here, their observations reveal a no-man's land, an inner zone cleared by the voracious appetite looming ahead. A cloud of super-hot gas is swirling around it. The black hole pulls the gas in, then spews much of it back out. Now things get really strange. What you are seeing is not the stuff of Hollywood special effects. It represents the first time scientists have visualized the journey into a black hole. Their guide is Einstein and what his equations tell them. Space here is so warped, the black hole acts like a giant lens, twisting the light that scatters across it. At last, we cross the event horizon, the point of no return. But don't expect the inside of the black hole to be dark. Swirling within is a maelstrom of energy and matter. Hidden in the chaos is a single point where the black hole's mass is packed, known as the singularity. Now imagine there's an eye to this storm, magically made calm, so all the strange predictions of Einstein's equations can play out. We'd be greeted by a passageway, an escape hatch in space and time known as a wormhole. Through it, we enter a white hole. Here, the same twisted logic holds in reverse. Instead of being drawn in, all light and matter are flung out. But to where? A wormhole is just the thing for a science fiction character in need of a quick getaway to another universe. Unless the truth be told, the inside of a black hole is too violent a place for a wormhole to actually form, let alone for the likes of us to venture. This is nature's ultimate fury, destruction on a scale beyond comprehension. Or is it? In fact, it's simply the workings of a restless universe. A long time ago, when this black hole was young, powerful winds roaring from it seeded our galaxy with elements. They may have helped form a sun and planets, and some beings who could look into the sky and ask, what is a black hole? Our search for the answer is turning up dark mysteries and radiant revelations. Secrets stolen from the other side of infinity.
Revolutionized ideas about the origin of life on Earth. Scientists now believe that the building blocks of life originally came from space. Meteorites containing amino acids have bombarded Earth ever since the planet formed, and it was these amino acids which were the starting point for all life. Hunting for the origin of Earth's water and life, the investigation has revealed that the water on Earth arrived here inside meteorites. And meteorites also brought amino acids, the building blocks of life, to Earth from space. Scientists now need one more piece of the puzzle to explain the final stage in Earth's journey. From particles in the solar dust cloud to a planet where life itself builds Earth's geological features. 4.5 billion years ago, Earth formed out of the solar dust cloud. 200 million years later, the first continents and oceans were developing. Meteorites brought water and amino acids, the building blocks of life, to the surface of the planet. The investigation now moves forward to the period 3.5 billion years ago. New forms of life were about to emerge, which by their very existence would create new kinds of rocks. But life as we know it needs oxygen. 3.5 billion years ago, there was no oxygen on Earth. At the time, the atmosphere was deadly poisonous. Volcanic eruptions filled the air with a choking mixture of sulfur, methane, carbon dioxide, and sulfuric acid. But primitive life forms did exist. The fossilized remains of strange coral-like structures have been found in rocks more than 3 billion years old in many parts of the world. They are called stromatolites, and they are a clue as to how the atmosphere filled with oxygen. Living stromatolites are incredibly rare. One of the few places on Earth where they can be found is in another part of the northern Mexican desert. This is the high valley of Cuatro Ciénegas.
You might think that this is just any old desert, but it's not. This is a very special place because of particular way the chemistry is in this valley. It's unlike any other place on the planet.
The pool is like a time capsule laboratory. By examining the modern stromatolites, scientists can work out how they were made more than 3 billion years ago.
What's interesting about Cuatro Ciénegas is that this is almost like a proxy to right before the world had a lot of oxygen in it. And the place was dominated, our Earth was dominated by microbial life.
Seifert has discovered that the stromatolites are made by billions of microbes called cyanobacteria.
These right here are the stromatolites that are here at Cuatro Ciénegas. I have a piece of it here, and if you can see this blue-green rim right here, this is millions and millions of cyanobacteria.
These bacteria were to change the course of Earth history because of one unique feature. They produce oxygen.
Here at this pond, we can actually see them doing their job. We can see them making that oxygen. So when I get in the water and I actually go up to one of these cyanobacterial mats, if I look very closely, all of the community is making oxygen. And as that oxygen collects in that mat, it produces a little air bubble. And you can watch that air bubble just transfer to the top, and that's actually when oxygen is being released to the atmosphere.
3.5 billion years ago, oxygen was deadly poisonous to other early life forms, which used sulfur to obtain energy.
Cyanobacteria developed a little molecular machine that could actually take sunlight and take water. And they made a byproduct that was oxygen. Well, on this planet back then, none of the life was used to oxygen. And it's at that point in life's history when they began making excess oxygen that got into the atmosphere, our whole world changed in the way it worked.
Over geological time, there were enough cyanobacteria to produce trillions of tons of oxygen, creating the atmosphere we breathe today. And they were responsible for changing the way all life evolved.
From an evolutionary standpoint on planet Earth, we are where we are because of cyanobacteria and the fact that they managed to fill our atmosphere full of oxygen. Because unless we'd had that gas, we wouldn't have the complex organisms that we have on the planet. You and I wouldn't be here today.
Once the atmosphere began filling with oxygen, the stage was set for the evolution of all plant and animal life. The impact on Earth's geology was profound. Over hundreds of millions of years, decaying plant matter from tropical forests built up compressed layers, which eventually formed all the coal, oil, and gas deposits on the planet. Sedimentary rocks like limestone and chalk are made largely from the skeletons of marine animals which accumulated at the bottom of shallow seas. Without life, Earth's geology would be very different. The investigation into the birth of the Earth has uncovered evidence revealing the secrets of
4.6 billion years ago, our sun started to form about 2/3 of the way out on one of the spiral arms of the Milky Way. Our Sun is a third-generation star, starting from gaseous clouds and dense nebulae containing many heavy elements. It condensed under the inexorable pressure of gravity until it was hot and dense enough to experience nuclear fusion at its core. As stars go, our Sun is an average yellow star. But it is so massive that it contains 99.8% of all the mass in the solar system. Its radiant energy supports almost all life on Earth, and it drives Earth's climate and weather. It is almost 900,000 miles in diameter. It has a core temperature of about 15 million degrees, and its surface temperature of about 6,000 degrees. The Sun will be fairly stable over the next 5 billion years, at which time it will enter its red giant phase. It will expand enormously so that its outer layers will reach the current orbit of Earth, giving it a diameter of almost 200 million miles. After that, it will live a few billion more years as a white dwarf. Mercury is the smallest planet in our solar system. It is only about 3,000 miles in diameter and has a surface that is pockmarked with craters like our own moon. It is the innermost planet and has an elliptical orbit that takes it within 28 million miles of the Sun at its closest approach, and out to 43 million miles at its most distant. It takes Mercury 88 days to orbit the Sun. And figure this out, sports fans. Although it rotates once every 59 days, the day on Mercury is 176 Earth days long. Oh, it doesn't really have a tail. We added the one in the video to make it easier to see and to show its orbit. And although the scale is correct for the size of the Sun relative to Mercury's orbit, we are showing the planet 100 times larger than it would be if it were to scale as well. Except for the Sun and the Moon, Venus is the brightest object in the sky. And since it is closer to the Sun than we are, it shows phases like the Moon. Shrouded in permanent clouds, Venus rotates on its axis every 243 days, and it rotates backwards from the other planets. It is only slightly smaller than the Earth, and it orbits the Sun every 225 days, at a mean distance of 67 million miles. But its surface is terribly inhospitable. The atmospheric pressure at the surface is 92 times that of the Earth, similar to the pressure a half a mile down underwater. Its temperature is a balmy 900 degrees Fahrenheit. All in all, not a good vacation spot. Our Earth is 8,000 miles in diameter and rotates on its axis, causing sunrise every day. It is the largest of all the planets that have a solid surface, and it possesses an unusually large moon for a planet of its size. Since the moon circles the Earth, we think of the moon's motion as circular. But since the Earth-Moon system revolves around the Sun at about 65,000 miles per hour, the moon's motion in the solar system isn't much different from our own. At 93 million miles from the Sun, the Earth is the third innermost planet, and is the only place in the solar system that we know of that has liquid water. Mars is the planet most similar to Earth in terms of habitat. Although smaller than Earth and Venus, it has a thin atmosphere and probably had liquid water on its surface in the past. This attracts our interest and has prompted us to send a plethora of probes. It has 2 orbiting irregular-shaped rocks graciously called moons, which are probably captured asteroids. A day on Mars lasts about 24 hours, very comparable to our own. The volcano called Olympus Mons, or Mount Olympus, is the highest known mountain in the solar system. It is an extinct volcano and is over 3 times the height of Mount Everest. Mars is the 4th planet from the Sun and completes its orbit every 2 Earth years. Jupiter is huge. If it had only been a little larger, it could have become a brown dwarf star circling our Sun. It is a gas giant and has no solid surface. Its atmosphere forms bands of poisonous clouds that circle the planet in opposite direction. The giant red spot is a huge storm that has been raging for hundreds of years. 4 of its many moons are so large that Galileo spotted them with his primitive telescope in 1610. In addition to moons, all of the gas giants have rings, but Jupiter's rings are so faint they are not visible. The 5th planet out, Jupiter orbits the Sun at a distance of 480 million miles and takes almost 12 years for one complete circuit. Notice the large separation between the orbits of Jupiter and Mars. This is the realm of the asteroid belt. It is the debris of a planet that failed to form because of Jupiter's gravitational influence. Saturn is the 2nd largest of the planets. Only Jupiter is larger. Like all the gas giants, it has a system of rings. And the rings of Saturn are glorious. Like Jupiter, Saturn also has dozens of moons, and one of them is particularly notable. Titan is the 2nd largest moon in the solar system, and it possesses an atmosphere remarkably like Earth's. It is primarily composed of water ice and rocky material. It is even possible that under the clouds and surface ice, Titan has liquid water and maybe even microbial life. It is 50% larger in diameter than our own moon and 80% more massive. Saturn takes 29 years to orbit the Sun, and does so at a distance of 890 million miles. Uranus rolls on its side. It is an icy giant of a planet, the 3rd largest in the system. Like the other giants, Uranus has a ring system and numerous moons. It is the 7th planet out, and it orbits the Sun at a distance of 1.9 billion miles. A year on Uranus lasts 84 Earth years. Because of its extreme axial tilt, seasons on Uranus are worth a look. At the time near the solstice, one pole continually faces the Sun, while the other faces away. Only a narrow strip near the equator experiences Uranus's 17-hour day. At the other side of Uranus's orbit, the orientation of the poles is reversed, so each pole gets 42 years of continuous day, followed by a 42-year night. Okay, let's head to a point high over the ecliptic, so we can see the relative sizes of the orbits of the sunward planets. Neptune is a blue world. It is the smallest of the giant planets in our system, but still 30,000 miles in diameter. Since the demotion of Pluto, it is the furthest planet from the Sun. Neptune's rings are very faint, and of its 13 moons, only Triton is massive enough to be round. It rotates every 16 hours and orbits the Sun every 165 years at a distance of 2.8 billion miles. Pluto is now deemed a dwarf planet and a member of the Kuiper Belt. The Kuiper Belt is a region of the solar system that extends just beyond the orbit of Neptune, at about 2.8 billion miles out to about 5 billion miles. Like the asteroid belt, it is crammed with many small bodies orbiting the Sun, most of which are frozen methane, ammonia, and water. Here's a size comparison. Earth, Ganymede, Titan, our moon, and several bodies from the Kuiper Belt. Currently, the largest known Kuiper Belt bodies are Eris, Pluto, Sedna, and many more without formal names like FY9 and EL61. A day on Earth is a deceivingly simple concept. Today we'll examine that day on Earth in detail, perhaps uncovering a few surprises. A day is the length of time it takes the Earth to spin 360 degrees on its axis. Or is it 361? Here is a simple model showing the Earth, the Sun, and some background stars. The Earth travels around the Sun in an ellipse, with the Sun at one focus. The model, of course, is not to scale. Let's begin our examination at noon one day. The Sun is directly above the red line. That will be our reference point. Watching from a high vantage point, we see the Earth complete 360 degrees of rotation. But during that time, the Earth has also moved a bit in its orbit. So even after a 360-degree turn, the Sun is not directly above the same point on Earth that it was at the beginning of the spin. It is not noon of the next day. The red reference line needs to spin a little more than 360 degrees to get us to noon. The 360-degree rotation is called a sidereal day, while the noon-to-noon rotation is called a solar day. Earth orbits the Sun once for about every 366.26 sidereal days, and once for every 365.26 solar days. Not only that, the length of the solar day varies throughout the year, and for two different reasons. First, because of its orbit is an ellipse and not a circle, the Earth moves faster when it is near the Sun and slower when it is further from the Sun. So the little extra amount of rotation that the Earth needs to do to get from noon to noon changes throughout the year. Second, because the Earth is tilted on its axis, the little extra rotation to get from noon to noon is largest at the solstices and smallest at the equinoxes. So solar days grow progressively longer as we move from equinox, March and September, to solstice, June and December. And did we mention the Earth's spin is slowing down? And the length of the solar day is increasing due to gravitational tides between the Earth and the Moon? The length of the mean solar day is increasing at a rate of approximately 1.4 milliseconds every century. 2 billion years ago, there were about 750 days in a year. Now let's talk about daytime. That period out of 24 hours when it is light outside. Day versus night. Due to refraction and scattering of light by the atmosphere, there can be daylight even when the sun is slightly below the horizon. But day length is usually about the sun's disk being on or above the horizon. So the day begins the moment the sun's disk appears during sunrise and ends the moment the sun's disk disappears during sunset. At the equator, daytime and nighttime are equal to within a few minutes. But at distances north and south of the equator, the length of the day varies with the season, with the longest and shortest days being on the solstices. At the poles, once the sun has risen, it stays up for 6 months before it sets again. And during the course of each day, it travels in a complete circle around the edge of the sky. Because the Earth travels at different speeds in its orbit, the sun is north of the equator for almost 4 days more than half the year, and the length of the average day in the northern hemisphere exceeds the length of the average day in the southern hemisphere by a few minutes. In the northern hemisphere, the Arctic Circle is the southernmost latitude where 24-hour daylight can occur at least 1 day in a year. In the southern hemisphere, the Antarctic Circle is the northernmost latitude where 24-hour daylight can occur at least 1 day in a year. And daylight savings time is like the old man who cut off one end of the blanket and sewed it on the other end to make it longer. A year on Earth is measured by one complete trip around the sun. Seems simple enough, but there is a problem. The Earth doesn't travel in a path around the sun that returns to its starting point. So how do we know when a year starts or ends? Well, one way, called a sidereal year, measures our orbit against the distant stars. As viewed from the Earth, our orbit causes the sun to appear to move through the constellations of the zodiac on a path called the ecliptic. And when the sun returns to its starting point, a sidereal year has passed. This motion is difficult to observe directly because the stars cannot be seen when the sun is in the sky. However, if you look at the sky before each dawn, the annual motion is very noticeable. The last stars seen to rise are not always the same, and within a week or two, an upward shift can be noted. As an example, in July in the northern hemisphere, Orion cannot be seen in the dawn sky, but in August, it becomes easily visible. Measuring a year this way gives a period that is 365 days, 6 hours, 9 minutes, and 10 seconds long. Another possibility is to measure the year against the passing of the seasons. Because of the tilt of the Earth on its axis, the position of the sun in the sky changes from day to day throughout the year. If we were to take a picture of the sun at noon regularly throughout the year,
we would see the sun moving on this path called an analemma. On the days in its orbit when the Earth is at a maximum tilt towards or away from the sun, the length of the daylight is at a maximum or a minimum. These days are called solstices, and the sun will be at the top left or bottom right of the analemma. On the days when the Earth's tilt is perfectly sideways to the sun, the day and night are equal in length. These are the equinoxes, and the sun will be at a latitude-dependent position in the analemma. When the sun goes from one vernal equinox to the next, a tropical year has passed. Measuring this way gives a year that is 365 days, 5 hours, 48 minutes, and 46 seconds long.